In this posted question, we don't have a clear statement of what they're asking us to do, but I'm going to assume that they want us to test the hypothesis that the two means are equal to one another. So let's start out with that as our claim. We're going to claim that the mean for California is equal to the mean for New York. Now, from there, I can then write, of course, an alternative hypothesis and a null hypothesis. So the null hypothesis will be the same as the claim since it has an equal to sign. And for the alternative hypothesis, I'll go ahead and use a not equal to symbol. The opposite of equal to, of course, is not equal to. Okay, so that's my claim, my null hypothesis, my alternative hypothesis. From there, I usually collect the data, but that's already been done for us here. And then I will calculate my test stat after that. So I'll take my test stat formula and write it down. So the test statistic formula will essentially be a z formula here. It's a z formula because we have the population standard deviations known, and both the sample sizes are large, so both 45, large enough to assume that the test statistic would have a normal distribution. And when we have the population standard deviations, we can certainly assume that the z distribution applies. This depends on the class. Some classes just use the large sample size criteria. Others require that you know the population standard deviation as well as large sample sizes. So in this case, either way, we can assume that the distribution is going to be a z distribution. Now from here, the test stat formula is pretty simple. We will have the sample mean for the first group, which we've called California, minus the sample mean for the second group, which we've called New York. Then sometimes you'll see like a minus d sub 0. I'll talk about that in a moment, but for now, don't worry about that quantity. Then we'll have the square root of, and so this is going to be the standard error of the estimator. And this standard error is basically sigma for the first group squared divided by the sample size for that first group plus sigma for the second group, in this case New York, squared divided by the sample size for that second group. Okay, so we have these values. We know the sample means. They tell us that California sample mean was 64,510. We know that the New York one was 62,900. Now, this d sub 0 would have to be stated in the claim, where maybe they'd say, we think there's a difference of $5,000 between these two means, then we'd have this number to be 5,000. However, they don't tell us that. In fact, we don't even have a statement of a claim here, so we'll just assume that they want us to test to see if they're equal to one another, in which case this value is 0. Now, that value is almost always 0. It's very unusual in elementary stats classes for them to give you a stated difference, but if they did, it would be something stated in the claim. It would say something like, test the claim that teachers in California make on average $5,000 more than teachers in New York. Something like that, where we'd have a difference stated in the claim. We don't have anything like that here, so we're just going to assume it's 0. So this number we can cross out and just make it 0 in this case. Now, under that, we'll put this square root. We'll have the standard deviation for the California group squared. So the standard deviation is 8,200. And then we will square that quantity. And we'll divide by the sample size. The sample size here is 45. Then from there, we will go ahead and add the standard deviation, which is 7,800. And we will square that and then divide by the sample size again, which is 45 once again, because they said they took 45 samples from each of the states, right? So that's your test stat. All right, let's go ahead and work that out in the calculator, see what that gives us. So putting it all at once, it'd be 64,510 minus 62,900. And then we'll close that up and then divide by the square root of, and we enter in the other two quantities, 8,200. We're going to square that, and we're going to divide it by 45. And then we're going to add to that 7,800 squared and divide again by 45. Now, once that's done and you close up the square root, press enter and you get the following answer, which is simply 0.954, or in other words 0.95 if you want to round to the traditional 2 decimal places for a z-score. So 0.95 is your test stat. So not a very large test stat. This is not going to fall into the rejection region. To be sure, though, we do have to come up with the rejection region. So let's go ahead and do that. The rejection region for a z-test will fall on a bell curve, of course. And when I draw the curve, I would indicate that it has two tails, two rejection regions, because the not equal to sign in the alternative hypothesis indicates a two-tailed test, the same as it always has. Now, they didn't give us an alpha in this problem, just like they didn't tell us that it was even a hypothesis test, so I'm going to assume the alpha is 5%. That's sort of the default alpha. So let's go ahead and assume that alpha is just 0.05, and if that's the case, it means it's 0.025 in each tail. Because it's two tails, we have to split it up into two regions. That's important. Then from there, the center here would be at 0, and we're trying to figure out the critical z-scores that go here and here. Now let's go to our table and look that up. Since we're dealing with a z-test statistic, we're going to look for the critical z-values that are associated with 0.025 in one tail. Alright, so here we are on the table, and we're looking area in one tail. Now I'm on a t-table. Remember, at the bottom of a t-table, you have critical z-values in the very last row. So if I look up my area in one tail as 0.025, and I go straight to the bottom of this table, I will find the corresponding z-score that's associated with that area. And we find that number to be 1.960. That means that this will be 1.960, and this will be negative 1.960. Now, of course, we can see that this test stat does not fall into the rejection region. It's right here, and therefore it's going to be in the do not reject the null hypothesis region. So that means we're saying do not reject here. So do not reject the null, and therefore you do not support the alternative. Remember, those go together, right? If you don't reject, you don't support. And that means that as far as our claim is concerned, it's a null hypothesis, so we're going to say we do not reject the claim. So that's our final conclusion, essentially, that we do not reject the claim. So let's try to remember that that's the wording we need to use. We cannot reject the claim that the two means are the same.